Hi, this is Mike Adams, the Health Ranger here, editor of naturalnews.com. At the Natural News Forensic Food Lab, this is what you're seeing. I'm going to explain to you today how I discovered tungsten in rice protein. But I wanted to show you some of the sweet new equipment that we have online here. This is a new pump system from Glass Expansion. It's called the Niagara Plus. This has been really working extremely well. It's a new sample introduction system that has a very short tube here going into the nebulizer. So it has valve control cycling system so that it greatly reduces the amount of time that you need to spend in rinse cycles, which of course reduces the load on your sample cones in here, and also your plasma torch inside here. So it's some really sweet equipment. I'll probably do a review of that later. Really good stuff. This is our auto sampler right here, of course. Some of my agitation systems. This is some of the racks of things we've got going on. Some additional equipment happening there. This is my face mask for the nitric acid digestion process, which takes place in here. We've got a hot block digester here. We've got some nitric acid. We've got some external standards of different metals. But I wanted to show you actually something up here, because this is really how I discovered tungsten in brown rice or rice protein products. Now, if you go over here and take a look at this is a periodic table reference chart for atomic spectroscopy. You can see tungsten here, and of course mercury is here. And I wasn't even looking for tungsten. I was actually looking for mercury. But if you go over here to the ICP-MS mass selections with percent elemental abundance and ionization potentials, if you look, for example, at mercury, these are the ionization potential columns. But what I'm really interested in on mercury is here, which shows the isotopic abundance percentages in nature. These are the atomic mass units for mercury: 199, 200, 201, and 202. And this chart shows you the relative abundance of those different isotopes in nature. For example, mercury in mass of 202 exists at about 29.9% in nature. But what's really interesting is if you go over to tungsten, which is W, you'll find that tungsten has these percentages in nature at atomic mass 186, 184, 182 are the real predominant ones. Now these two here, 184 and 186, if you add oxides to those, which is an oxygen atomic mass unit of 16, then they will overlay. And they will overlay mercury at 200 and 202, because 184 plus 16 is 200. Yes, we can still do math because we weren't taught Common Core. So, and 186 plus 16 is 202. So when you look at the mercury isotopes of a rice protein product that you digest here, and run through all of this equipment here, run through the auto sampler, run through the ICP-MS unit here, through the sample introduction system, the plasma torch, the mass analyzer that's in this instrument, what you end up with is a very interesting peak, or a Twin Peaks type of situation, where you see mercury at 200 and 202 artificially heightened, while the 201 isotope remains very, very low, lower than normal relative to 200 and 202. That tells you that you've got tungsten in your rice protein. And then once you have that clue, you can do a separate test for tungsten. And in order to do that, of course, you need, well, what do we have right here? Tungsten. This is a tungsten external standard from Inorganic Ventures, and this is what we use as part of the process of creating the external standard in order to test for tungsten. We've got a lot of other standards in here, of course. Here's mercury right here, a mercury standard. Here's a custom standard that we had manufactured for us, and here's some gold right here that we use to spike some of the samples in order to maintain mercury in those samples. So this is some of the big secrets right here, and I wanted to explain this because I'm the only person in the history of food science research that has ever discovered tungsten in rice protein powders. And some people scoffed at it, said, yeah, you must be making this up. It can't be true. How could you have come up with this? Well, this is how. Tungsten and mercury atomic masses, isotopes 184 and 186 plus 16 from the oxides equal 200 and 202. I always look for multiple isotopes in the ICP-MS data analyzer report. So I see 200, 201, and 202. For example, when I'm looking at lead here, I'm looking at 206, 207, and 208. As you see, lead, right? Right there. I'm not just looking at one of them. I'm not just looking at 208. I'm looking at all three to make sure that they line up. And when I saw something curious here in mercury that did not line up, I knew I was onto something interesting. That's how I discovered tungsten in rice protein. So there you go. That's the explanation. It's not rocket science. It's atomic spectroscopy. And this is the instrument that it works on. So I'll probably do a review of all this instrumentation later just to show you how cool this is. I actually put all this together myself, assembled the plumbing and everything. This is a sample tube here. This is the uptake line from the auto sampler. This is in the peri pump here. This is the waste line, the beige one in the back. If you can see that, that's the waste line. This is the internal standard here in the middle. And then this is the sample uptake tube here. This is, well, I'll just show it all to you later in a separate review. These are the argon tubes here that bring in the argon to the plasma torch. And I'll actually show you this in motion so you can see it rocking and rolling. It's pretty cool. Plasma torch on, auto sampler rocking, getting good scientific data here, blowing people's minds who don't realize that anybody can do science. Science is accessible to anyone who wants to study the table of elements, who wants to learn scientific principles, who wants to understand ICP-MS, mass spectrometry, and elemental abundance as they appear in nature. Anyone can learn this, and I'm living proof of it. So thanks for watching. Spread the word. This is Mike Adams, the lab director of the Natural News Forensic Food Labs.